we all know we're having a hot dog and cotton candy thing going on. In the spirit of an excellent year of safety, we're going to have that whole carnival thing, and we're also going to play with liquid nitrogen.
And so, hopefully not get hurt.
Yes, so without further ado,
really
Mike, why don't you take it away?
All right, guys, thank you for coming. We are going to describe a little bit about liquid nitrogen, give you the science behind it first, and then we're going to show you some pretty cool demonstrations and have some fun with it if you can. So if any of you are wondering how it's actually made, you do take room air, basically standard atmospheric air, and you compress it under 3,000 pounds per square inch, and you literally heat it up as you're compressing it, and you cause it to expand. You run that through coils, kind of like a heat exchanger, and you cool the air that's running through those coils. That air then comes back in and is allowed to expand as it cools down, and you do that process again. Each time you do that, the air keeps dropping in temperature, dropping in temperature. Eventually, the air gets so cold that it actually can't expand anymore. It instantly changes to liquid, which becomes liquid nitrogen at that point. Obviously, liquid nitrogen is extremely cold. You can see the temperatures down here, minus 321 Fahrenheit. To give you an idea, dry ice, which everybody knows is really, really cold, this is 3 times colder. Absolute zero is even colder than this. It's minus 273 Celsius. If you ever heard of liquid helium, that gets really close to absolute zero. That's actually the coldest material on the planet. And it's a couple of degrees above absolute zero. Can't get any colder than that. Some of the uses for liquid nitrogen here, you can do freeze-dried food. NASA uses this a lot. Chefs use it to create exotic dishes. They flash freeze certain things like ice cream and gelatin, and they make molds out of it. Obviously, in the medical industry, you can remove warts and moles using liquid nitrogen. Computers, you can actually overclock computers. You literally pour the liquid nitrogen into a cooling chamber in a computer, leaving it open, and the actual cooling fins absorb that liquid nitrogen. It lowers the electrical resistance and allows the CPU to run faster. You can literally double the speed of a computer using this process. But it evaporates very quickly, so it costs a lot to do it. So only geeks do it. No, I don't do it while I'm here. Industry. Some of you have heard of shrink fitting. You can actually shrink one piece of material and slide it into another piece of material, let it come back up to room temperature, and it locks itself in place. Liquid nitrogen is used for that a lot. We use it here. We have 2 large tanks of liquid nitrogen out in the rolling room in the vacuum melt department. And what we do is they're low pressure liquid nitrogen. We don't need a high pressure. We literally run a line directly into a furnace. By the time that liquid gets to the furnace, actually long before it turns into gas. We purge pure nitrogen into the furnace, bigger than atmospheric pressure, so that we have a positive pressure in our vacuum melt rolling furnace. If we didn't do that, obviously there's many materials that will oxidize very quickly in an oxygen atmosphere. So this is good for that. It's also a 1/7 of the cost of argon, which is actually why we're using it here now. The way we use it is not the greatest way. It's not really efficient. We'd like to have a nice giant tank like the argon tank out there and just have the guys flip a switch, but that's what these are for. They turn it on, they switch it back and forth, and it works. Safety, obviously. Here's some of the safety gear for liquid nitrogen. This is probably about $600 for the gloves and the apron. I can basically throw liquid nitrogen against me in a small quantity and it won't harm me at all. This suit is designed for that. Anything more than that, it will start to hurt. This face shield is specially designed for cryo fluids, basically. Same principle. A regular plexiglass face shield would not do well against this stuff, basically. I am supposed to wear guards on my feet, which I don't have, obviously, when I'm filling it. If I were to fill this and spill liquid nitrogen into my shoe, it'll get trapped in my shoe and start boiling right away and cause immediate frostbite. I'll probably have to amputate my foot. So I'm really careful when I fill it. Sometimes I'll even put the apron over my shoes when I actually fill it. But out here, there's not enough here to hurt me. It'll evaporate by the time it hits my shoe. So I have my PPE here. I am going to give you an idea. If you look up there, you'll see that if you talk about a cubic centimeter of this liquid, it can actually expand 700 cubic centimeters of gas. It expands really fast. It's basically boiling all the time and turning into vapor. So fast that it becomes extremely dangerous if you try to seal it in a container. For instance, if I were to pour this liquid nitrogen in this thermos right here and seal that off, about 15 minutes from now, this will be a half a stick of dynamite. Literally, this whole room will go up. But it's also very safe if you know how to deal with it. I'm not going to seal it. This styrofoam container is full of pores and full of air holes, so it's always expanding while it's in here. I'm going to give you a demonstration about the expansion right now. And in here, I'll let you look at it later on, but it does look like water. It is, standard clear liquid. You'll see it a little bit while I pour it. Pour a really small amount. There we go. I have no choice but to expand. Expanding to 700 times its size right now inside the kettle. God, I wish I could pull the top off and get Jim a little bit. That's cool. This the first time we've done this experiment today. It's the second time today, but we've never done it before. Obviously it's boiling. I think we're at almost 400 degrees hotter than the liquid right now in this room, at 70 degrees Fahrenheit. So it's an insane amount of temperature change for that. So it's boiling like crazy. It's already gone. All that liquid's gone. So we talk about severe burns with liquid nitrogen. If I were to get this, basically if I were to take my hand, I'll do this right now for you, just to give you a difference. This liquid is right about here. So if I were to dip my hand really quick, what's going to happen? Anybody? Breathe. So why did that happen? Why am I still okay? Remember about the temperature difference? Yes. So basically 400 degrees hotter, I put it inside, instantly vaporizes all the liquid around my hand, it causes a shield, literally forms a shield. And it boils it, turns into vapor, and my hand does not get hurt. I mean, you can do this all day long at this speed. However, if I were to cup the liquid basically like this and close my hand to it in fist, I'm not allowing anywhere for it to escape. It's going to start boiling right away, start expanding right away, and I'm going to get frostbite on my hand immediately. Anytime you close this, it becomes a problem. If I submerge my hand and leave it in for a while, eventually my hand comes to equilibrium, same temperature of the liquid. I start to kill my blood cells, I start to kill my tissue, and in about 5 minutes my hand will go completely frostbite and I'll lose it forever. It takes a decent amount of time, but you don't want to screw around with it that way.
How long did you say? 5 minutes?
About 5 minutes. I mean, that's the theory, nobody's done it yet, so. Suffocation too, believe it or not. If I basically take about a tank about the size of this table, about this high of liquid nitrogen, I cut this room in half, and I take no ventilation whatsoever, all the air conditioning is everything is off, we'll be dead in about 20 to 30 minutes. It'll basically just asphyxiate all of us. Because of course our air is full of 80% nitrogen. If we had 100% nitrogen, we die. If we have 100% oxygen, we die. We need the mixture of nitrogen, oxygen, hydrogen, and the other things in our air.
Well, we practice with this stuff upstairs, and to do it, we use the elevator, but Mike sent it by itself on the bottom, and I pulled it out the top.
That's a very, very good point. Obviously, if I walk into the elevator with this on a cart, and the elevator door closes, and the elevator gets stuck, I'm dead in about 30 minutes. There's no ventilation in there. It's just continuing to boil away and starting to condensate the oxygen out of the air and take it away from literally the air. So, like you said, you send it up, we meet on the other side, and we bring it back out. So, obviously there's some stupid people out there that do stupid things with liquid nitrogen. We're going to do some of them today. I don't recommend doing what this hippie's doing here. He literally drinks the liquid into his mouth and he blows it out. He can do that because of what we talked about before. His mouth is really, really hot. It does boil it and it does evaporate quickly. As soon as he closes his mouth, he's done. He loses his tongue. Some professors have done this for a long time and they've actually lost their taste buds entirely. So I don't do that. And whoever this kid's dad is obviously dad of the year. He's letting his kid pour liquid nitrogen into his computer to overclock it with no safety glasses or anything. One droplet that kind of bounces out and hits the kid's eye, he's blind in that eye. So he's just an idiot. But we'll do some stupid stuff today, but not that stupid. All right.